Hello and welcome to the series that we're going to start on setting up AI in Unity. We're going to use this using the AI library that's built into Unity, particularly with NavMeshes and NavMesh agents. The tutorial files that we're going to use here are found on the forums. This is just a simple kind of setup, kind of Riverwalk sort of idea. It's important because I want to show how we can get AI to go over bridges and things like that. The AI system in Unity can do lots of cool things. You can train it to jump over ledges, crawl up ladders, do all sorts of things, although we're going to be using kind of a simple setup here. Now, in order for this to work, the first thing we need to do is make sure that Unity knows what parts of the mesh are navigatable, that we can walk upon. Now, when we were doing the Unreal chapter, then we looked at NavMesh volumes there. In Unity, it works much the same way. What I'm going to do is I've got all of the set in one group. Now, all of this already has colliders on it, but what we want to do here is make sure that the set is marked as navigation static. So you just come over here, click on navigation static. It will ask you if you want all the children, which we do. We want everything that's inside of that set to also be set to navigation static. But just because we've marked it as navigation static doesn't mean that Unity has calculated what the navigation mesh should be. So in order to do this, we can do a couple different things. The easiest way is to just come over to the navigation tab here. Yours will probably be empty like this, but there are several tabs over the top here. These have to do with everything from how big and tall the agent is, what it interprets an angle as being something that we can walk up, and what ends up being a wall, what it interprets as a step, and what it interprets as a wall, for instance. But the way that we will bake this is you just come to the Bake tab and click on Bake. It just takes a second. But once that's done, then you'll see this NavMesh. It's this blue shape that's over the top of things. Now, there's several things about this that are important. One, you can see that it's actually built up over the top of the stairs. And two, you can see how it's worked through spaces here on the walls. Now, you can actually change that. For instance, if I reduce that NavMesh radius and rebake, then you'll see that the NavMesh gets tighter and tighter to the options. You have to kind of play with that. Probably the default there will be okay. What this does, though, is that this blue stuff here is areas that the NavMesh agents have permission to walk upon. Now, you'll see that down inside the river that we've got that as well. But right now, it would never get to it because it would kind of get up to the end of here, decide, I can't move on, and so it wouldn't jump in here. Now later, if we wanted to, we could build nav meshes that would allow us to jump into places. And you can also do some kind of cool stuff with areas that have to do with a cost, so that they'll all avoid the river until a monster jumps down, and then they'll be willing to walk through the river, or things like that. But for here, we're going to keep things much simpler. Okay, so the set. Now you can see if we click on the navigation tab, you can see that we've got the nav mesh there. What we need to do now is build in the mechanism so that our little elements will be able to walk around. Now to do this, I'm going to do this in a pretty simple setup. I'm going to create a 3D, let's do a cylinder. Let's not do a cylinder, we'll do a capsule. I'm going to do a 3D capsule. We're going to make a tic-tac convention here. And this capsule, when I put it in here, it's got some things that we already need. For instance, it's got a collider on it, which will be good for other things. But what we do want to make sure is that it has a new component. I'm going to start to minimize some of these so we don't have to look at them. It has a new component here that will use that nav mesh, and this is called a NavMesh Agent. So I'm going to add a component, start to type in NavMesh Agent, and that will show up there. The NavMesh Agent will show up as this kind of cylinder that's set there. Now the cylinder, this NavMesh Agent, has everything from a base offset, meaning how far off the ground it's going to be. It'll have a speed, angular speed, acceleration, things like auto braking. It also has things like radius that you should be able to, in this case, kind of leave by itself, although you can change that as time goes on. But you'll also see that it also has things like pathfinding. Now this pathfinding is what makes this kind of a sophisticated method. So to make use of this, we need to write a little bit of script. So let's create a C# script that I'm going to call AI script. And this AI script will start to build the methods to talk to it. So to get started with this, let's go ahead and open this up. As I look at this, then I need this script. This script is going to be actually applied to that capsule. So I need this capsule to first of all be able to access the Unity AI library. So I'm going to use Unity engine.ai so that it knows that particular brand of Kung Fu. And now that it does, then I need to make sure that the script is always able to talk to this component called NavMesh Agent. So I'm going to create a variable that's going to hold NavMesh agents that I'm just going to call my agent. So that anytime in the script, if I want to talk to that component, then I can just go to NavMesh, to my agent. And then I need to make sure that I let the script know what that is. So I'll just say on awake, my agent is going to be equal to go and get component, and the component we want to get is the NavMesh agent that's there. So from here on out, whenever we talk to my agent, then we're ready to go. Now, the most basic form of this would go something like this. Let's say that at start, I want this to go to a particular location. So I'm going to come back into Unity, and what I'm going to start to do here is build some waypoints. We're going to want this thing to kind of patrol different waypoints. So to do this, I'll make a 3D object. Let's just make a sphere. The sphere I'm going to kind of put over here. I'm going to put it fairly close to the ground. It doesn't need to be, but later on we're going to be measuring the distance between the NavMesh agent and a particular waypoint. And so the closer to the ground is, then that's going to be easier to kind of see. So you don't need to do this, but let me create a red material here that I'm just going to put on this sphere because I want to be able to see these pretty easily. Okay. So this sphere, I'm going to go ahead and call it Waypoint, WP. And what it'll do is I want to have this NavMesh agent move towards that waypoint. So simplest form is, let's say on start that what I want to have happen is my agent use some of the methods, one called setDestination. And the way that setDestination expects to work is that it's looking for a destination that is a vector 3. Okay, vector 3 target, you can see right there. So the way that I would do this is, let's make sure that this script knows where the waypoint is. So I'm going to make a public transform that I'm going to call Waypoint. And then at the start, what I'll have it do is move towards waypoint.position. All right, so I'll go ahead and save that. Come back over here. After compiling, I need to make sure that my AI script is actually on the object. It's going to ask what the waypoint is. So let's say, oops, I put that on the wrong object. Let's put an AI script on the capsule, and the capsule will need to know who where the waypoint is. So I'll drag the waypoint in there, so that this capsule will know to move to that waypoint. So when I start to play the game, then what will happen is that capsule knows that it's a waypoint. It can move along the space and move right over to the waypoint. All right, now that's great, moving to an individual waypoint, but that's also not very exciting. So what we want to do is, in order to make this really work like a patrol unit, is that what I'm going to do is change this instead to an array that I'm going to call waypoints, so that we have more than one. And then I'm going to start to build some other methods in here. One that I'm going to use again and again and again, called pick waypoint. The idea here is that I can call out this method where it will randomly pick another waypoint in the scene and then move towards that. So this I'll call pick waypoint. We'll build it like that. It doesn't need any input arguments. But then what I'll do is, let's create an integer called a random waypoint number. Okay. And then random waypoint number is going to be equal to a random value using random range between 0 and the length of the array waypoints. Okay, So you can just pick one, a number between 0 and however long the waypoint is. Then what we'll do is, instead of using this here, let's go ahead and grab this. And I'm just going to paste it right here. I don't want it to go to waypoint.position. What I want it to do is go to waypoints and use the number that I've just picked to define which waypoint it's going to use. And that will go to its position, and that will define what it is. So every time this method is called, it will pick a random number between 0 and the number of waypoints in the array. And then it'll use the NavMesh agent to set the destination to wherever the position is of that random waypoint. Now, at the start, I can make sure that I call this out. So I'm going to say pick waypoint here, so that it goes ahead and finds one of those. All right, back out into Unity. After compiling, I'm going to grab this waypoint here, and I'm going to make a few more of them. So I'm going to duplicate one, put one there. Let's duplicate one there, put one there. So we'll put one just for fun on top of a bridge to make sure we get up there. Okay, so what I've got is I got 4 of these waypoints set here. So I can come back to that capsule. The capsule now is asking for a waypoint and the size of these. I could just type in 4, or watch this trick. What you can do is come up here to the top right and lock down this so that it doesn't change out the inspector. And then what I can do is I'm going to select all 4 of these waypoints and drag them onto the word waypoints, and what it does is it fills all of those in. Now you have to make sure that you unlock this in the inspector after you do that, otherwise it'll always just show the capsule. It's easy to get confused, so remember lock and unlock. Okay, so the capsule now knows that it's got those 4 waypoints at start. It's going to pick one randomly and move towards it. So when I play, it looks like the one that it's picked is that one over there. So you can see that the path includes going over the top of bridges so that it goes over there and it'll just stop. Now that's great so far, but what we want it to do is that when it gets to a waypoint, in order for this patrol, we want it to go ahead and pick the next one. So to do this, in an update function, in other words, I want this to do this every frame, what I'm going to have it do is check to see if it's reached whatever its target waypoint is. Once it's reached it, we want it to pick another one. So I'm going to use the NavMesh agent called NavMesh agent function called remaining distance. So I'm going to look at my agent, and I'm going to see if my agent.remaining distance, by distance it means its distance to its currently selected target. If that's less than, let's say 0.25 units, then what I want it to do is pick another waypoint. So we'll just use pick waypoint like that. So at start, it goes and starts to move towards it. As it's moving towards it, every frame it's checking if it's less than 0.25. If it is, then it picks another one. So it moves on. So let's go take a look at what this does. So when I click play, then we'll see our NavMesh agent pick one. When it gets to that one, it will move on and pick another one. So it looks like it's moving on to this one. And then it's randomly picking another one, which looks like it's the one all the way down there. And then when it gets to that one, it'll randomly pick another one, define a path that will allow it to get to that new one, and move towards it. Okay, so let me do a little bit of setup off camera to make this a little bit more fun, and then we'll see what else this is set to do. All right, so what I've done is, let me close this down so that we don't see it all, is I've got a whole bunch of waypoints kind of set throughout. Got some of them inside of the stores here so that different waypoint agents will move in and out. And I've put one at the top of each of the bridges so that it's fun for it to kind of go up and maybe it'll spend some time up there. All right, so what I'm going to do is come back to my capsule here. Let's go ahead. I'm going to set this back to 0 for a second. Again, play the same trick that I lock it down so that I can grab all of these waypoints, drag them right onto the capsule waypoint word so it populates all 10 of those. And so what it'll do is this capsule now has a lot of different places to go. Now, just for giggles and kicks, I'm going to take this capsule and I'm going to duplicate it, I don't know, Let's try 20 times. When I hit play, they're all on top of each other, so they'll all kind of as they split up. But what will happen is each of these will now pick a random waypoint, and they'll start wandering towards that waypoint. When they hit the waypoint that they're after, then they'll go and start hitting the next one. So you can see that some of them will go up and down bridges, some of them will be moving to a waypoint on the bridge, some of them will be using a waypoint a bridge to get to the next waypoint that they're at. But you can see that these are moving around. They'll avoid each other. They won't go through each other as they start to build. Okay, so what I'm going to do is make a few minor adjustments to this, and then let's look at what this thing can really do. All right, to put this through its paces, I've written a real simple script here. Basically, I've set up an integer with the number of AI elements I want to spawn. I'm going to define what that spawn is and define a wait time. And so I've created an IEnumerator that I launch at start, that as long as the number to spawn is greater than 0, then I want it to instantiate one of those AI spawns wherever this script is attached, wait for whatever that wait time is, and then subtract 1 from the number to spawn. That way we can define how many are there. Now the way that I would use this inside of Unity is I'm going to create an empty game object. Maybe I'll just call this spawner. I'm going to just put this at 0, 0, 0 to get started with, and then maybe I'll kind of tuck this over here out of the way so that it's not happening kind of out in the middle of the world. So I'm going to have this little spawner that sits right back here. I'm going to make sure that my AI spawner is attacked there. My AI spawner is attached to that. It's going to ask for how many I want to spawn. So let's say that I say 10. The thing that I want it to spawn is this capsule, and let's tell its waiting time to be 1/4 of a second. What will happen is that when I hit play, then it will spawn 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and each of those will all go out and they all have the AI. So we can get crazy here. Let's say that we spawn 1,000 of them, and let's wait for 1/10 of a second from each. This will start to give you an idea of how robust and lean Unity can run actually. Let's duplicate another one over there so that that's there. Let's duplicate another, stick it over here. Let's duplicate another, stick it over there, so that we've got that set. Each of these at this point here, let's tell them each to spawn 10,000 of these. And so what will happen is that when we press play, each of these are going to be spawning another one of those AI elements every 1/10 of a second, and you'll see all of those going out about to shop. It's like suddenly church got out on the Riverwalk or something, a church that only uses Tic Tacs. And so all of these, oh look, they're sneaking around that side. I probably need to build something else there so that we can't cheat there. But you'll see that as they get closer to those elements, then they'll do it. Looks like we got some traffic jams up here as they kind of bounce through. Excuse me, excuse me, excuse me, excuse me. But you can see that we're just continuing to kind of chug along. Let's look at what our see, what are we doing here as far as frame rate? So I'm still getting 60 frames a second, 50 frames a second when I'm drawing both of them. But you can see those starting to get more and more. Now they're starting to kind of run into each other, right? We're starting to get these traffic jams where they can't get through. So maybe what we'll do is, just to make that a little bit easier, I'm going to start to make my Tic Tac maybe a little bit skinnier. This way and this way, so that they're a little bit easier to work with. And then let's tell the AI script that if you get to within 1 unit of your target, then you can go ahead and move on to the next. But what this should do, it's a little okay, is that when we press play, we should be able to get lots more in there. What we're running into is just problems with how much space is available for these many objects to work. We're not actually running into problems with how the AI works. Okay, so here's a simple way to get a good patrolling mechanism to work. This is using AI, using particularly the set destination and the checking for the remaining distance. Now, what we need to do is start to build this AI in so that when these characters, just like we did in the Pesky Little Cousins project, is I want them to be patrolling, but if I get close enough, I as in the player get close enough, I want them to abandon the control and start to come after us. Unless we get away. And then once we get away, we want it to go back to patrolling. So that's what we'll do in the next chapter. For now, try and get this up and running so that you understand the basics of Unity AI.